You mentioned earlier that the telescope is constantly observing space. So does that mean that we are just being sent images of space in real time right now?
Yeah, exactly. Sphere X orbiting the space, and it takes the images of universe every 2 minutes. So 2 minutes and 2 minutes, it constantly observing. During the day, it takes about 600 exposure, 600 times. And at each exposure, we got 6 images we gained. So 6 times 600, we got 3,600 images per day. So this huge amount of data. Yeah.
But if it takes 3,600 photos a day, is this too much for astronomy to analyze on their own? Like, do you get any help from AI? Or
Yeah, of course. That exactly. PX is operating 2 years from now. So it's huge amount of data, and then you cannot handle that with my desktop or even in laptop. So we are using very high performance computing center resources in the US and Korea. But in the end, right now the data is very complex and so brand new data. So right now this analysis needs human intervention, right? So we really take a look at all the images and found interesting stuff. But in the end, as you said, I mean, if we develop enough experience on this data, we will we use AI and machine learning kind of the technique to analyze data because there's too many data. Yeah.
So why does it have to be infrared?
infrared?
Infrared.
Yeah. So the infrared is allow you to actually see the invisible. So visible light is a normal light, which is a usual light you can see in the space. But infrared is beyond that wavelength. If you use infrared, you can see something that you cannot see with normal eyes. And usually the universe is expanding faster. When universe expanding, the light from the early universe expand more. They are redshifted to this infrared wavelength. So if you want to see that really far distance universe, the frontier of the astronomy, you need infrared light. Yeah. That's why astronomers are rely on these new kind of wavelengths.